We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning friends. Today we are going to solve the problem of spiral, okay, in chapter engineering curves. Okay, in question given that the point P move toward the another point 75 mm from it. Okay, so point P and O are at 75 mm distance. Okay, so here point P and point O both are at a distance of 75 mm. Okay, and point P reach to the point O, okay, and 1 revolution means 1.25 revolution. Okay, here distance between point P and O is 75 mm. Point P reached to the point O after 1 revolution. Okay, so if I draw here one vertical and horizontal line, okay, then point P is moved toward the O and it's also rotate clockwise direction. Okay, so in clockwise in this direction. Okay, so when the point start rotating, okay, it's move in this direction also, so its radius is decrease. So when it's come to the here, it's complete 1/4 revolution. Okay, then it's come at here. Okay, then it's complete its half revolution. Okay, then again it's come at here, then it's complete 3/4 revolution. Okay, then again it's back at here. Okay, it's complete 1 revolution. Okay, and it reached to the point O after complete 1 and 1/4 revolution. Okay, so point P is moved toward the O and it's also rotating, okay, about this pole. O is a pole. Okay, then its radius is continuously decrease. Okay, and we generated this spiral curve. Okay, let's see the steps how to solve this problem. Okay, so here point P and O at a distance of 75 mm. 75 mm. Okay, this distance is 75 mm. Okay, so first I draw one circle with O as a center and OP as a radius, means O as a center and 75 mm as a radius. I first draw one circle at here. Okay, so first I draw this circle with O as a center and OP as a radius. Now I divide this circle into equal 12 parts. Okay, divide this circle into how many parts, it's depend on us. Okay, in this problem I divide this circle into 12 equal parts. Now point is moved in clockwise direction. Okay, so I start the name from here. Here I give 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, now I divide this line OP into equal parts. Now divide the line OP into how many equal parts is decided by this equation. Okay, equal parts of line is equal to equal parts of circle into number of revolution or convolution. Here we divide this circle into 12 equal parts. Okay, number of revolution or convolution given is 1 and 1/4, means in 5/4. Okay, so we get the answer 15. Okay, so divide this line OP into 15 equal parts. Okay, this distance OP is equal to 75 mm. Okay, so we divide the 75 mm line into 15 equal parts. Okay, so 5 mm each parts. Now here I divide the line OP into 15 equal parts and give the number in this direction. Okay, 1 2 3 4 5. Okay, remember this point, we always give the number from P to O. Okay, 1 2 3 4 5 up to 15 at point O. Okay, now I take O as a center and O21 as a radius. Okay, O21 as a radius. I draw one arc which intersect the line O1. Okay, I take O1 as a radius. Okay, and draw one arc which intersect this line O1 at here. Okay, so here I get my first point. I start from here P0 and here I get my first point P1. Okay, now in a similar way, now I take the distance is equal to O2, radius is equal to O2, and center as I always take O as a center. Okay, I just change the radius. Okay, now I take O as a center and O2 as a radius. I draw another arc which intersect the line O2. Okay, so here I get my second point of the spiral curve P2. Similarly, O as a center and O3 as a radius. I draw another arc which intersect at here. Okay, so here I give the name P3. Now O4 as a radius. Okay, so here I get my P4 point. Okay, now I take O5 as a radius and draw the arc. Okay, now I take O6 as a radius and draw the arc which intersect the line O6. Okay, so I get my point P6. Okay, similarly now I take O7 as a radius and draw the arc which intersect the line O7. Okay, so here I get my point P7. Now I take O8 as and draw the arc which intersect the line O8. Okay, so I get my point P8. Now I take O9 as a radius and O as a center, draw another arc which intersect the line ON. Okay, so I get my point P9 at here. Now I take O10 as a radius and O as a center, draw another arc which intersect the line O10. Okay, so I get my point P10 at here. Okay, now I take O11 as a radius and draw arc which intersect the line O11. Okay, so I get my point P11 at here. Okay, I get the P12 point at here. Okay, here we give the number up to 12. Okay, but we divide the line into 15 equal parts. Okay, so we continue number in this direction. So at here 13, 14 and 15. Okay, so now I take O13 as a radius. Okay, and O as a center, draw another arc which intersect the line O13 at here. Okay, so here I get my point P13. Now I take O as a center and O14 as a radius. I draw another arc which intersect the line O14 at here. Okay, so I get my point P14 at here. Okay, and I get the P15 point at the here. Okay, now I just simply connect all the points. Okay, remember one thing, that we start from the P0. First connect P0 to P1. Okay, so here we get our final spiral curve. If you count the revolution or convolution, then we start from here. Okay, at here 1/4 revolution, half revolution, 3 by 4th revolution, 1 revolution, okay, and 1 by 4th revolution, okay. So point P is reached to the point O after 1.25 convolution, okay, or 1 1/4 revolution. Okay, let's draw the normal and tangent. Okay, here for drawing normal and tangent, first I select one point at here and give the name A. Okay, so we draw the normal and tangent from point A. Okay, so first I find the value of constant. Constant is equal to, okay, here I take two vector radius, one is OP0 minus OP3, okay, OP3 divided by the angle between these two vector radius. Okay, here I take OP0 and OP3, so angle between this is 90 degree. Okay, but I take the value of angle in form of radians, so pi by 2. Okay, so OP0 is 75 mm distance, 75 minus this distance OP3 is 60 divided by pi by 2. Okay, so I get the answer 9.54 mm. Okay, now I take 9.5 mm as a radius and O as a center. Draw one circle, concentric circle at here. Okay, here I draw the circle with a 9.5 mm as a radius and O as the center, this circle. Now from point A I draw the tangent on this circle. Okay, I draw the tangent on the side at which spiral curve is moved away from the center. Okay, here I get the tangent, one tangent at here and one tangent at here. Okay, but in this direction spiral curve is moving toward the center. Okay, so I draw on this side, because on this side curve is moved away from the center. Okay, its radius is continuously increase. Okay, so I draw the tangent in this direction at here. Okay, so this tangent give me the normal of the spiral curve, and line perpendicular to this normal give me the tangent of the spiral curve. Okay, I explain again. Here from point, first I select the point A. Okay, then I find the value of constant, okay, by taking two vector radius. Okay, here I take OP0 and OP3, okay, and divide the angle between these two vector radius is pi by 2. Okay, so I get the value of 9.54 mm. Now I take 9.54 mm as a radius and O as a center. Draw one circle at here. Okay, now from point A I draw the tangent on this circle, okay, in the direction at which the spiral curve is moved away from the center. Okay, so I draw the tangent at here. Okay, so this line N is normal for our spiral curve, and I draw the line perpendicular to its normal is give the tangent to the spiral curve. Let's come to the second problem. In this problem, given that draw the Archimedean spiral of 1.5 convolution, the greatest and least radius being 95 mm and 5 mm respectively. Draw the normal and tangent. Okay, so here if I take point P at here and center O as here, then point P is not reached up to the point O. Okay, because here least radius given is 5 mm. Okay, so point P is reached up to 5 mm distance from point O. Okay, so here there are two radius is given. Greatest radius means point P to O, and second radius is 5 mm, okay, which is away from the point O. So first I draw the two concentric circle, first with a 95 mm radius and second with a 5 mm radius. Okay, so here two circle, one with a radius of 95 mm, OP is a 95 mm, and second radius I here give the name Q. Okay, OP is equal to 95 mm and OQ is equal to 5 mm distance. Okay, now I divide the circle into 12 equal parts. Okay, now here direction is not given, so I take the anti-clockwise direction and start the number from here. 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, now here I divide the line to equal parts, okay, by using equation. Okay, equal parts of equal parts of line is equal to equal parts of circle into number of revolution. Okay, here we divide the circle into 12 equal parts, and number of convolution is equal to 1.5. okay, number of convolution is 1.5, means 3 by 2. okay, so here we get the answer 18. Okay, now here I divide the line PQ into equal. Okay, remember one thing, here we not divide the line PO. okay, we divide this line QP or PQ, because greatest and least radius given is 95 mm and 5 mm. okay, so we draw the spiral between the P and Q point. okay, and divide the line PQ into equal parts. We use this equation. okay, equal parts of line is equal to equal parts of circle into number of revolution. okay, here we divide the circle into 12 parts. okay, number of convolution is 1.5. okay, so 12 into 3 by 2. okay, so we get the answer 18. so we divide this line into 18 equal parts. okay, divide the line PQ into 18 equal parts and give the number in this direction. okay, now I take O as a, okay, remember one thing, we always take the O as a center. okay, center of this two concentric circle. okay, we always take O as a center. Now I take O as a center and O1 as a radius. I draw one arc which intersect this line O1. okay, so here I get my first point P1. okay, now I take O2 as a radius and O as a center, draw another arc which intersect the line O2. okay, so I get my second point of the curve at here P2. now I take O3 as a radius and O as the center, draw another arc which intersect this line O3. okay, so I get my P3 point at here. okay, now I take O4 as a radius and draw another arc which intersect the line O4. okay, so I get my P4 point at here. now I take O5 as a radius and draw arc which intersect the line O5. okay, so I get my P5 point at here. now I take O6 as a radius and draw arc which intersect the line O6. so I get my P6 point at here. okay, now I take O7 as a radius and draw the arc which intersect the line O7. okay, so I get my P7 point here. okay, similarly I get all the point. okay, here we divide the line into 18 equal parts. okay, so and circle into 12 equal parts. okay, so I continue number from here: 13, 14, 15, 16, 17 and 18. okay, so if you count the convolution, then first we start from 1 to 12. okay, and then 12 to 18. so 1 plus half, so 1.5 convolution. okay, so now I take O13 as a radius and O as a center, draw the arc which intersect this line O13 at here. okay, so I get my P13 point at here. similarly now I take O14 as a radius and draw the arc which intersect this line O14 at here. okay, so here I get my P14 point. okay, similarly I get all the points up to P18. okay, now I simply connect all the point. okay, first start from here P0, P1 to P2, P3 to P2, P10, P11, P12, P13, P14, P15, P16, P17 and P18. okay, so our last point at here. okay, its distance from point O is 5 mm. okay, because this circle is radius of 5 mm. okay, so for spiral, greatest radius is equal to 95 mm and least radius is equal to 5 mm. okay, now for drawing the normal and tangent, I select one point at here. Okay, I give the name A. Okay, now first I find the value of constant. Okay, an equation of constant is equal to, I take any two vector radius. Okay, first I here take the O P0 and second is O P3. Okay, here I take two vector radius O P0 and O P3. Okay, and divide it by the angle between these two vector radius. Okay, here first O P0 and second O P3. Okay, here P3. So O P3, and angle between these two vector radius is 90 degree. Okay, but we write the angle in form of radian. Okay, so it's pi by 2. Okay, find the value of constant by using this equation. Okay, I take any two vector radius. Okay, I take OP0 minus OP6. Okay, but then the angle between these two vector radius is 180, so I take OP0 minus OP6 divided by pi. Okay, here I take OP0 and OP3, so the angle between this is pi by 2. Okay, so I take OP0 minus OP3 divided by pi by 2. Okay, here distance OP0 is 95 mm, and we measure this distance OP3, it's 81 mm, and divided by pi by 2. Okay, so I get the value of 8.91 mm. Okay, so now taking 8.91 mm as a radius and O as a center, I draw one circle at here. Okay, so here I draw this circle with 8.91 mm as a radius. Okay, now from point A I draw tangent on this circle. Here we have two tangent on this circle. Okay, one at here and one at here. Okay, but we always draw the tangent on the side where the spiral curve is moved away from the center. From point A, if I think that on this side all the points are moved away from the center, means its distance or radius is increased. On this side curve is moving toward the center. Okay, means its radius is continuously decreasing. Okay, so we always draw the tangent on the side where the spiral curve is moved away from this. Okay, so from these two tangent I draw this tangent. Okay, this tangent is normal for the spiral curve, so I give the name N, and perpendicular to this normal I get my tangent. Okay, you not required to draw these two tangent, you only draw this tangent. Okay, I draw these two tangent to explain you. Okay, so in exam you draw the tangent on the side at which the spiral curve is moved away from the center. Okay, means its radius is increasing. Okay.